scariest creatures in the world. These are not myths. These are not legends. These are not prehistoric animals that went extinct before humans existed. Every single creature on tonight's list is alive right now, on this planet. In some cases, closer to you than you would like to know. Tonight, 6 of them. Fear is supposed to be a survival mechanism. It is supposed to warn us away from things that can kill us. But evolution designed human fear for a specific range of threats. Large predators, heights, darkness, hostile members of our own species. It did not design us for the actual range of things on this planet that can end a human life. Some of the most dangerous animals in the world are the size of a thumbnail. Some of them live in water that looks completely safe. Some of them are in your region right now, and you have walked past them without knowing it. Tonight, 6 creatures that prove evolution underestimated what we needed to be afraid of. Creature number 1, the Cone Snail. It looks like a beautiful shell on a tropical beach. Collectors have picked them up for centuries. Some of them died within minutes. There is no antivenom. There has never been one. The Cone Snail, genus Cones, with over 700 species distributed across tropical and subtropical oceans worldwide, is one of the most efficient killing machines in the natural world, housed in one of the most beautiful objects nature has ever produced. The shell is the attraction, smooth, intricately patterned, ranging in color from cream to vivid orange to deep purple, often in patterns so geometrically precise they look designed. People have collected them for centuries. Museums hold thousands of specimens, and some of the people who picked them up on tropical beaches did not survive the experience. The killing mechanism is a harpoon. Hidden inside the cone snail's body is a hollow, barbed tooth, the radula, attached to a highly flexible proboscis that can extend in any direction, including backward, meaning that holding a live cone snail by its wide end is not a safe strategy. The harpoon fires into whatever the snail identifies as a threat or prey, injecting a venom, conotoxin, of extraordinary potency and specificity. Different cone snail species have evolved different venom compositions, each targeting specific aspects of the nervous system. The geography cone, Conus geographus, is considered the most dangerous, with a venom that blocks neuromuscular transmission so completely that it produces full-body paralysis within minutes, followed by respiratory failure. There is no antivenom for cone snail envenomation. There has never been one because the venom is too complex, a mixture of dozens of distinct peptide compounds, each affecting a different biological target, to neutralize with a single anti-serum. Victims who survive do so because of rapid access to mechanical ventilation to support breathing until the venom clears. For those who don't have that access, beachgoers, divers, people who pick up a beautiful shell on a remote tropical beach, the survival rate for Conus geographus envenomation without medical intervention is low. The shell that kills you will probably be the most beautiful thing you ever hold. The cone snail has been refining this venom for millions of years. It is very good at it. Creature number 2, the Irukandji Jellyfish. It is the size of a fingernail, transparent, almost invisible in the water, and its sting produces a syndrome so terrifying that victims have begged doctors to kill them to escape the pain. Carukia barnesi, the Irukandji jellyfish, was formally described by science in 1964, though its effects on humans had been documented in Queensland, Australia for decades before anyone identified the cause. The animal itself is extraordinarily small. The bell, the dome-shaped body, measures approximately 1 centimeter in diameter. 4 tentacles extend from the bell, each one capable of independent stinging. It is transparent, almost entirely invisible in the water, and produces no sensation at the moment of contact, no immediate pain, no visible mark. Nothing to suggest that anything has happened at all. What happens next is called Irukandji Syndrome, and it is among the most comprehensively terrifying medical experiences in the documented record. Beginning approximately 30 minutes after the sting, the victim experiences an escalating cascade of symptoms: severe lower back pain, muscle cramps, nausea, vomiting, sweating, anxiety. And then, as the syndrome progresses, a phenomenon that medical literature describes with clinical understatement as a feeling of impending doom. This is not a metaphor. It is a specific, documented symptom, a profound, consuming conviction that death is imminent, a psychological state so overwhelming that multiple documented cases exist of Irukandji syndrome patients begging medical staff to end their lives to escape what they were experiencing. The mechanism involves a massive release of catecholamines, the stress hormones that include adrenaline, triggered by the venom's effects on the nervous system. This hormonal surge produces hypertension so severe that it can cause cardiac arrest, pulmonary edema, and stroke. The feeling of impending doom is not irrational in these cases. The body is, in fact, in genuine danger. Irukandji syndrome is potentially fatal, and its geographic range appears to be expanding as ocean temperatures rise. Documented cases now extend beyond the Queensland coast, where it was first described, to waters that were previously considered safe. A creature 1 centimeter across, invisible in the water, that produces a medical syndrome so severe that its primary symptom is convincing the victim they are about to die. It lives in water that looks beautiful. It always has. Creature number 3, the botfly. It doesn't sting, it doesn't bite, it doesn't even touch you directly. It glues its eggs to a mosquito, and the mosquito does the rest. What hatches inside your skin is the part that stays with you. The human botfly, Dermatobia hominis, is native to Central and South America, ranging from southern Mexico through most of tropical South America. The adult fly is large, robust, and entirely harmless. It does not sting, does not bite, and causes no direct injury whatsoever. What it does instead is considerably more disturbing. The female botfly captures other insects, most commonly mosquitoes, but also other biting flies, and glues her eggs to their bodies. When that mosquito lands on human skin to feed, the warmth of the body triggers the eggs to hatch, and the larvae immediately burrow into the skin through the mosquito's bite site or through a hair follicle. What follows is an experience that dermatologists describe with clinical precision and that patients describe with considerably more emotion. The larva develops inside the skin over a period of 6 to 10 weeks, feeding on the host's tissue and growing from a tiny grub to a larva approximately 2 centimeters in length. It maintains a breathing hole at the surface. It produces a distinctive sensation, described by those who have experienced it as a feeling of movement beneath the skin, punctuated by sharp pains when the larva shifts position. The host is not in significant medical danger. The botfly larva is extraordinarily careful not to damage its host fatally, because a dead host is an unlivable environment. It is, in this sense, considerate. It simply lives under your skin for 2 months, breathing through a hole in your flesh until it is large enough to emerge. The botfly's geographic range is expanding as tropical climates extend further from the equator due to climate change. Cases in travelers returning to North America and Europe have increased significantly over the past 2 decades. The removal of a botfly larva requires either smothering the breathing hole to force the larva to emerge on its own, a process that can take hours, or careful surgical extraction, which risks rupturing the larva and causing infection. The botfly is not trying to harm you. It is simply using the most effective incubation environment available. The fact that the most effective incubation environment available is a living human being is not, from the botfly's perspective, your problem. Creature never before. The candiru, a freshwater fish from the Amazon, smaller than a finger. For over a century, indigenous communities warned explorers about it. For over a century, scientists dismissed those warnings. Then the first documented case arrived in a Brazilian hospital. The candiru, Vandellia cirrhosa, is a small catfish, rarely exceeding 5 centimeters in length, that lives in the rivers of the Amazon basin. It is parasitic. It feeds by entering the gill chambers of larger fish and feeding on their blood, using backward-pointing spines to anchor itself in place. For most of its existence in the scientific record, it was considered an unremarkable parasitic catfish, one of many such species in the Amazon's extraordinary diversity. What made it extraordinary was the claim, documented in indigenous oral tradition and in the accounts of numerous explorers and missionaries from the 16th century onward, that the candiru was capable of entering the human urethra. The claim was dismissed by most Western scientists for most of the 20th century. It was considered anatomically implausible, culturally exaggerated, and lacking in documented cases. Then, in 1997, a documented case arrived at the Hospital Universitário Betina Ferro de Souza in Belém, Brazil. A man reported that while urinating in the Guatumã River, a candiru had entered his urethra. The surgical removal, which required 3 separate procedures over an extended period, was documented, photographed, and published in a medical journal by urologist Anwar Samad. The specimen was preserved and is now in the collection of the Goeldi Museum in Belém. The case exists. The fish exists. The dismissal ended. The mechanism by which the candiru navigates to this location has been debated ever since. The original hypothesis, that it was attracted to urea in the urine stream, has been challenged by subsequent research, and the exact sensory trigger remains incompletely understood. What is not debated is the outcome of an encounter, which requires surgical intervention and carries significant risk of infection, hemorrhage, and permanent injury. The candiru is small enough to be invisible in river water, lives in rivers that are used for bathing and swimming throughout the Amazon basin, and has been documented in at least one case to behave exactly as indigenous communities warned it would for centuries before anyone in a laboratory was willing to believe them. Creature Zabrier 5. The Death Stalker Scorpion, the most venomous scorpion on Earth, responsible for 75% of all scorpion-related deaths worldwide, and it is specifically attracted to human shelter. It prefers to live inside houses. Leiurus quinquestriatus, the death stalker scorpion, is distributed across the arid regions of North Africa and the Middle East. From Algeria through Egypt, Israel, Jordan, Saudi Arabia, and into Pakistan. It is not the largest scorpion in its range, at approximately 10 centimeters. It is actually relatively modest in size compared to some of its relatives. Size, in the scorpion world, has almost no relationship with danger. The death stalker's venom is a complex mixture of neurotoxins, including chlorotoxin, agitoxin, cilatoxin, and charybdotoxin, each acting on different ion channels in the nervous system. producing a cascade of effects that include severe pain at the site, followed by fever, convulsions, paralysis, pulmonary edema, and in vulnerable populations, children, the elderly, and individuals with compromised cardiovascular systems, death. The death stalker is responsible for approximately 75% of all scorpion-related fatalities worldwide. Despite the fact that there are over 2,500 scorpion species on Earth. This disproportionate lethality is a function not just of the venom's potency, but of the scorpion's behavior and distribution. It is a synanthropic species, an animal that thrives in human-modified environments, specifically human dwellings. It shelters under stones, in crevices, in shoes, in clothing left on the floor, in bedding. Communities across North Africa and the Middle East experience deathstalker stings with a frequency that generates significant public health concern. In some regions, scorpion envenomation is a leading cause of pediatric emergency hospitalization. Antivenom exists, and in regions with adequate medical infrastructure, it has dramatically reduced the fatality rate. But the deathstalker's range includes large areas of rural poverty, where antivenom and medical care are not readily accessible. Where a child stung at night by a scorpion that climbed into their bedding may not reach a hospital in time. The deathstalker does not seek out humans. It seeks shelter, warmth, and prey. The fact that human dwellings provide all three is not the scorpion's doing. It is simply using the best available habitat. And the best available habitat across a vast stretch of the world's most populous region is wherever humans are. Creature number 6. The Japanese giant hornet, the largest hornet in the world. A stinger long enough to pierce a beekeeping suit. Venom that dissolves human tissue. And it can fly 100 kilometers in a single day to find a target. Vespa mandarinia, the Japanese giant hornet, now also established in North America as the Asian giant hornet, is the largest hornet species in the world, with queens reaching 5 centimeters in length and a wingspan of up to 7.5 centimeters. Its stinger is approximately 6 millimeters long enough to penetrate standard beekeeping gloves and suits that protect against the stings of smaller species. The venom it injects contains, among other compounds, an enzyme called phospholipase A2 that breaks down cell membranes, producing tissue necrosis, literal dissolution of human flesh, at the sting site in severe cases. It also contains a pheromone that, in the presence of multiple hornets, functions as an attack signal, a chemical instruction to every nearby hornet to sting the same target. A single sting from Vespa mandarinia, while extremely painful and medically significant, is not typically fatal to a healthy adult without allergies. Multiple stings are a different matter. The Japanese giant hornet kills approximately 30 to 50 people per year in Japan. Not through individual encounters, but through mass stinging events in which a person who has disturbed a nest receives dozens or hundreds of stings in a short period. The cumulative venom load produces systemic toxicity, organ failure, and death within hours if untreated. In Japan, Vespa mandarinia causes more human fatalities annually than any other animal, including venomous snakes. In 2019, the Japanese giant hornet was first detected in North America, initially in British Columbia, Canada, and subsequently in Washington State. The detection generated significant concern, not primarily because of its danger to humans, but because of its ecological impact. Vespa mandarinia is a specialist predator of honeybee colonies, capable of destroying an entire hive of 30,000 bees in a matter of hours. A small group of hornets, sometimes fewer than 50 individuals, enters a hive in what entomologists call a slaughter phase, decapitating every bee in the colony with their mandibles in a process that takes approximately 90 minutes. The established populations in North America have been the subject of intensive eradication efforts. Whether those efforts have fully succeeded is a question that entomologists are still answering. The hornet that can fly 100 kilometers per day to find a target is patient. It has time. If this video made you think twice about where you swim, walk, or sleep, share it with someone who thinks nature is friendly. Subscribe so you don't miss what's coming next. And before you go, which of tonight's creatures scared you most? Drop it in the comments. We read every single one. And if there's a creature you think belongs on this list, tell us below. You might just see it next week. See you there. Nature is not trying to kill you. It just doesn't care if it does.